A Sci Amazing Day, Sci folks! Your Sci Energetic teacher is back to join you in exploring, discovering, and enjoying life. I know that your Sci-oriented minds are now excited to absorb information. So allow me to be with you as you learn. Be sure you have your pen, your paper, and everything you need for this learning session. This is your teacher MJ. Welcome to another Sci wonderful episode of DepEd TV. Do you enjoy taking a sip of coffee? Well, I do, especially during frigid mornings and of course when the weather is cold. What about having a night jam with your friends in front of a bonfire while enjoying your lightly grilled marshmallows? What about having your favorite ice cold drink? Well, we enjoy things differently. Someone thinks hot, someone thinks cold. But as we enjoy whatever happiness these things give us, there is a bit of science going on behind it. Do you know what it is? Yes, it is the science of heat and temperature. This week, we are going to talk about heat and temperature and the things that would explain things you might not have known all this time. So be with me as we go through this lesson. Let's go! Before we start, try answering the following questions to excite your brain and to find out how far you know about the concept of heat and temperature. What average energy of particles does temperature measure? A. Kinetic, B. Potential, C. Chemical, or D. Mechanical? A. Kinetic. What happens to the temperature of an object when the particles are moving faster? A. Reduces, B. Increases, C. Remains constant, or D. Increases then reduces? B. Increases. Does the temperature of a substance depend on how much the substance is present? A. No, B. Yes, C. Maybe, or D. None of the above? A. No. Which of the following is not a unit of temperature? A. Calorie, B. Celsius, C. Fahrenheit, or D. Kelvin? A. Calorie. The normal body temperature is 37 degrees Celsius. What is this in Fahrenheit? A. 32 degrees Fahrenheit, B. 99 degrees Fahrenheit, C. 212 degrees Fahrenheit, or D. 373 degrees Fahrenheit? B. 99 degrees Fahrenheit. Did you get all the correct answers? Well, if not, there's nothing to worry about. At the end of our lesson, I'm sure you will be enlightened. With no further ado, Let's get moving! Are heat and temperature the same? The common thinking of people regarding heat and temperature is that they are the same. In physics, although heat and temperature are related to each other, these two terms are not the same. Let's try to dig deeper as to how these terms are different. Let's start by talking about heat. So what is heat? Heat is a form of energy that transfers from one body of higher temperature to another body of lower temperature. Heat transfers from one body with a certain temperature to another body with a different temperature through conduction, convection, and radiation. To better understand that, take a look at this. If I dip a metal spoon, which has a normal temperature, in a glass of hot water, the heat from the water will be transferred to the spoon through the conduction of heat. Another example, when it is cold, you tend to enjoy the heat near a fireplace or a bonfire, and your distance from the fire depends on how much heat your body wants to absorb. As you feel cold, and as you stay close to the fire, a certain amount of thermal energy from the bonfire is transferred to your body through radiation. That heat radiated towards you is a tolerable heat that gives your body comfort from a low temperature. The SI unit for heat is joule. Another common unit of heat is calorie, defined as the amount of heat needed to change the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atm. ATM stands for atmospheric pressure, and the normal atmospheric pressure is 1 atm. To avoid confusion, a calorie is not used to refer to an amount of heat. It is used by dietitians or nutritionists to specify the energy content of food. Now let's proceed with temperature. Temperature, on the other hand, is the measure of the hotness or coldness of a body, object, or substance. When you have a fever, you usually check how hot your body is by basically putting your hands on your neck or forehead. This is very typical for everyone, as a high temperature usually indicates a fever. The normal temperature of the body is 37 degrees Celsius. And if that goes higher, something might be wrong. Aside from just using your senses, there is a more accurate way to measure temperature. What do we use to measure temperature? Do you have any idea? That's right, a thermometer. Temperature describes the average kinetic energy of molecules in an object or substance. The higher the kinetic energy, the faster the molecules move, and thus the temperature is higher. The three common temperature scales are Celsius, Fahrenheit, and Kelvin. Andrew Celsius introduced the Celsius scale in 1741, while Daniel Gabriel Fahrenheit introduced the Fahrenheit scale in 1724. Both scales use the freezing and boiling points of water as reference points. On the Celsius scale, the freezing point of water is 0 degrees Celsius, while its boiling point is 100 degrees Celsius, under a pressure of 1 atm, having 100 intervals between two reference points. On the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit, while its boiling point is 212 degrees Fahrenheit, having 180 intervals between two reference points. The difference between these two reference points is divided equally into intervals called degrees. William Thomson, also known as Lord Kelvin, introduced the third temperature scale, which is called Kelvin. This scale is based on absolute zero corresponding to 0 Kelvin. It is the lowest possible temperature, and it is when the molecules of the substance have the lowest energy. The Kelvin scale cannot have negative temperatures. On the Kelvin scale, the freezing point of water is 273 Kelvin, while its boiling point is 373 Kelvin. The temperature difference is 100 Kelvin. The difference in the temperature between two reference points in the Celsius scale is also 100 degrees Celsius. So when we compare the Kelvin and Celsius scales, in terms of change or difference in temperature, 1 Kelvin is equivalent to 1 degree Celsius. So there you have it, our three temperature scales. Now, have you ever wondered what happens to substances as their temperature changes? Let's find out. When the temperature of a substance changes, its molecular structure and movement also change, which results in what we call phase change. There are different types of phase changes or transitions such as melting, solidification, evaporation, and condensation. Fusion or melting is the process that causes a solid to change to its liquid state. The amount of heat required to produce this change is called the heat of fusion. When liquids release heat, the water molecules begin to move at a slower pace. The space between the molecules becomes compact. The process of changing liquids to solids is called solidification or freezing. When water boils, evaporation takes place. Heat is absorbed and water is converted into steam or water vapor. The amount of heat needed for a liquid to evaporate depends on the boiling point of the liquid. When water vapor releases heat, its gas state changes to the liquid state through condensation, which accounts for the formation of clouds in the water cycle. Some other forms of phase changes are sublimation and deposition. Sublimation is the process of transforming a substance from the solid phase directly to the gas state without passing the liquid phase. This requires additional energy. Deposition is the process of transforming a substance from gas to solid without passing the liquid phase and requires a release of energy. During any of these phase changes, energy is either given off or taken in. When a substance changes phase, the temperature does not change. Only the amount of energy changes. Now that we know more about heat and temperature, I hope that you will now be able to distinguish how these two terms are different. To test that, it's time to check your comprehension by answering the following questions. Let's do the Psy quiz. Who introduced the absolute temperature scale? A. Anders Celsius. B. Gabriel Fahrenheit. C. William Rankine. Or D. William Thomson. D. William Thomson. Which expands the greatest when heated at the same temperature? A. Gas. B. Solid. C. Liquid, or D. All expand equally? A. Gas. Temperature describes the blank of molecules in a substance. A. Potential energy. B. Kinetic energy. C. Thermal energy. Or D. Gravitational force. B. Kinetic energy. Which of the following is not a unit of temperature? A. Fahrenheit. B. Celsius. C. Calorie. Or D. Kelvin. C. Calorie. Why does liquid in the thermometer rise when put in hot water? A. The liquid is boiling. B. The liquid is evaporating. C. The liquid gains heat from the hot water, causing it to expand. Or D. The liquid loses heat from the hot water, causing it to contract. C. The liquid gains heat from the hot water, causing it to expand. That is all for today, Sci folks. I hope that the heat of information has been radiated into your minds and the temperature of your eagerness to learn continues to rise. See you again in our next episode, and we will together explore, discover, and enjoy life. This is your teacher MJ, and this is DepEd TV. Keep safe, everyone.